Hey guys, this video is on linear functions. We're going to look at graphs, tables, sets, and equations. The graph of a linear function is a straight line. So you can see in our three graphs that the first is linear and the second two are nonlinear. When you're given a table of values, you can quickly check to see if it represents a linear function. What you're looking for is a constant change in x that corresponds to a constant change in y. So first we're going to look from 1 to 2. You see a change of 1, 2 to 3 is a change of 1, and from 3 to 4 is a change of 1. From 3 to 5 is a change of 2, from 5 to 7 is a change of 2, and from 7 to 9 is a change of 2. So that table of values represents a linear function. In the second example, the change from 1 to 3 is 2, from 3 to 5 is 2, and from 5 to 7 is 2. Those are all the same, so we check y. From 12 to 15 is a change of 3, from 15 to 18 is a change of 3, and from 18 to 21 is a change of 3. So that's also a linear function. Now we're going to connect the tables that we just examined to their graphs. In the first table, 1 corresponded to 3, 2 corresponded to 5, 3 corresponded to 7, 7, and 4 corresponded to 9. Now you can see if you connect these blue dots that they form a straight line. So you can see that it's a linear function by looking at its graph. In our second example, 1, 3, 5, and 7 are the x values. 1, 2, 3, 4, 5, 6, 7. But my y values are too big to fit on my graph if I count by ones. So I'm going to count by threes. So 3, 6, 9, here's 12, here's 15, here's 18, and here's 21. Now 1 corresponds to 12, 3 corresponds to 15, 5 corresponds to 18, and 7 corresponds to 21. And you can see again that the points line up in a straight line, showing you in another way that it is a linear function. Now we're going to practice what we just learned. So we want to look for a constant change in x. From 1 to 2 is 1, 2 to 3 is 1, 3 to 4 is 1. That results or corresponds to a constant change in y. From 2 to 10 is a jump of 8, from 10 to 18, 8, and from 18 to 26, 8. So a constant change in x corresponds to a constant change in y. This one is linear. In the second table, from -1 to 2 is an increase of 3, from 2 to 5 is an increase of 3, and from 5 to 8 is an increase of 3. From 20 to 10 is a decrease of 10, and that's okay, you're allowed to subtract. From 10 to 5, however, is a change of -5. So as soon as you see these two numbers that don't match over here, these first differences don't match, you know that this is nonlinear. In the last table, from -5 to -1 is a jump of 4. From -1 to 3 is a change of 4. From 3 to 7 is a change of 4. From 1 to 1 is a change of 0. From 1 to 1 is a change of 0. From 1 to 1 is a change of 0. We have a constant change in x and a constant change in y. So this last one is also linear. We also want to examine linear functions from the point of view of a set of ordered pairs. We can use first differences exactly like we used it for the table. The first thing we want to check is the change from x to x. From 1 to 2 is 1, from 2 to 3 is 1, from 3 to 4 is 1, from 4 to 5 is 1. Check the y's. From 2 to 6 is 4, from 6 to 10 is 4, from 10 to 14 is 4, and from 14 to 18 is 4. So this is a linear function. Now we're going to practice that skill on these three sets. So first we check from x to x, making sure that the change is constant. And if it is, then we check the change in y's. And this one is a linear function. In the next example, from -3 to 0 is 3, 3, 3, and 3. So we have a constant change in x's. Now let's look at our y values. From 2 to 6 is 4, but from 6 to 18 is a change of 12. As soon as you see that, you know that it's non-linear. And in the last example, from 1 to 2 is 1, from 2 to 3 is 1, 3 to 4, 4 to 5. So we check y. From 2 to 6 is 4, 6 to 10 is 4, 10 to 14 is 4, and 14 to 18 is 4. So this one is also linear. The last thing we want to do is look at linear versus nonlinear equations. The first column has 4 linear equations. The second column has 4 nonlinear equations. I want you to notice the weird little things that you see in the nonlinear column. Okay, one of the things I see is the squared, that 2 on the variable x. I also see these absolute value bars. The third one looks pretty ordinary, but I'll tell you what the problem is. The problem is that xy means x times y. You're not allowed to multiply variables in a linear equation. And the last weirdness is that x being in the exponent position. When you look at the linear column, you see y and you see x. Plain old y, plain old x, with coefficients but no exponents. So it's understood that y is to the first and x is to the first. In a linear equation, you can't have a variable that's squared or cubed or with any weirdness about it. So notice all of these have x to the first and y to the first. Also notice that the third equation doesn't even have an x at all. That's okay, and we're going to learn more about that in subsequent videos. So you can see the differences between linear and nonlinear equations. Well, this is the end of this video. Thank you for watching.